Alright guys, so today I'm going to be going over module 13.3, and that's solving absolute value equations. If we first look at our essential question, it says, how can you solve an absolute value equation? So by the end of this lesson, you should know how to solve an absolute value equation and be able to answer this question. How do you do that? So first we're going to explore solving absolute value equations graphically, and we're going to kind of see what that would look like. So an absolute value equation differ from linear equations in that they may have two solutions. This is indicated with a disjunction, a mathematical statement created by connecting two other statements with the word or. To see why there can be two solutions, you can solve an absolute value equation graphically, or using graphs. So to start, it wants us to solve this. And since we're going to do this graphically, we're going to start by plotting this first part here as f of x or y equals 2 absolute value of the quantity x minus 5 at minus 4 on the grid. So the absolute value equation is a V graph, and in this case our vertex is 5, negative 4. And so I'm going to plot that, 5, negative 4. And then this number here, this 2, is my amplitude. And that tells me that I can go up 2 and over 1. Up 2 and over 1. And we're going to learn this with absolute values. You could go in the positive direction or the negative direction. So I'm actually going to go up 2 and back 1 as well. And that's going to help us create our V. So I like to plot multiple points in order to get a more accurate graph. So again, from here I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. And now when I connect these, I have one part of my graph. From here I went up 2 and back 1, up 2 and back 1, up 2 and back 1. I'm repeating my amplitude so that I'll get a more accurate graph here. So that's the first part that it's asked us to graph. So the next part says, then plot the function, which is y equals 2, or g of x equals 2, as a horizontal line on the same grid, and mark the points where the graph intersects. So where y equals 2 is this line here. And we're looking for where they intersect. So if I put a darker dot here and here, these are where they intersect. And we're looking for the x values that these are true. So this x value here is 2, and this x value here is 8. So now it says write the solution to the equation as a disjunction. So for this statement to be true, x can either equal 2 or x could equal 8. So this is the disjunction statement that they're talking about. X equals 2 or x equals 8 makes this statement true. Now, if we look at our reflect, it says, why might you expect most absolute value equations to have two solutions? Why not 3 or 4? So let's answer this first part here. Now that we know the graph of an absolute value is a V, there's really no point or no value here where it's going to cross this V graph 3 or 4 times. So let's say it was, the statement was equal to 6, still only hits the graph once here and twice there. So if we continue this, sorry my lines are not straight, but if you see, there's nowhere on here where it's going to intersect 3 or 4 times or anything more than that. Okay, if I show you with, let's go with this black line here, if it was here, how many solutions would this give us? Well, that would give us 1. But there's only one point on here where this is true. As far as no solution, well, if the line that we were trying to see if it could equal was below it, then there would be no solution. So why might you expect most absolute value equations to have two solutions? Well, from looking at this, there are multiple opportunities for that to be the case. Why not 3 or 4? Well, it's graphically impossible, so it's probably algebraically going to be impossible, which it is. So go ahead and give a reflection here. I'm not going to do that for you. We did discuss it. So if you need to, rewind the video and go through some of that logic in order to write that up. So the next one says, is it possible for an absolute value equation to have no solution, one solution? If so, what would that look like graphically? And again, we discussed that up here, talking about this black line and this gray line here. So you should be able to write your reflection for that piece as well. Now again, since this is a video, you can pause and take time to do that now. I'm going to go ahead and move on. So I'm going to go to the next page. So we were on 601, now we're on 602. And we're going to explain how to solve absolute value equations algebraically. So to solve an absolute value equation algebraically, you have to first isolate the absolute value expression on one side of the equation the same way you would isolate a variable. So we need to get this absolute value by itself and everything else on the other side. Now when this is true, so that's why it says if the absolute value is isolated, where a is a positive number, right? Absolute value is distance, so we have to have it equal to a positive number. You know, you wouldn't tell your friend you were -3 miles from their house. They might look at you like you're crazy. So that's why it has to be equal to a positive number. Otherwise, the statement itself does not make sense. If that's true, then we can split our absolute value to determine whether this inside one, or what two values, to determine what two values this x value can be. And so inside the absolute value, you can have a negative, right? Because the absolute value, let's say, of -3 is 3. Right? The absolute value always takes what's inside and makes it positive. If it's already positive, it keeps it positive. If it's negative, it makes it positive, right? You're talking about distance. So notice the use of a disjunction here in the rule for the values of x. You cannot know from the original equation whether the expression inside the absolute value bars is positive or negative. They're talking about this here. How do we know if it was positive or negative? We don't. So you must work through both possibilities and find which x values it could be. So step 1, we are going to isolate the absolute value. And then step 2, we're going to split this. So if I'm looking at example 1, it says solve each absolute value equation algebraically, graph the solutions on a number line. So A, this absolute value is not by itself. There's a +2 here. So the book says we need to subtract 2 from both sides. And when we do that, the inverse operations will go ahead and cancel out that +2 and that -2. And that leaves us with the absolute value of 3x equals 6. That was step 1. We isolated it. Now step 2, we're going to rewrite the two equations. So notice how we have a 6 here, and we write 3x equals 6, or 3x equals -6. We have to account for both positive and negative. And then we can go ahead and solve by dividing by 3 here, and we get x equals 2, or divide by 3, x equals -2. So when we plot this on a number line, we have -2 here, and we have +2 here. Those are the two values that make this the original equation true. Moving on to example 1b, we're going to isolate our absolute value. So in order to get rid of this -2, we're going to add 2 to both sides, and we're going to be left with 3 times the absolute value of 4x minus 5, or the quantity of 4x minus 5, equals, and then 19 plus 2 gave us 21. To get rid of that 3, because we need to isolate the absolute value by itself, we can divide by 3. and we get the absolute value of the quantity 4x minus 5 equals 21 divided by 3 is 7. Now since our absolute value is isolated, we can now split it. And notice when we split it, we don't carry the absolute value signs down with us. We're just taking the argument inside and setting that equal to the positive and the negative. Right, we're accounting for that absolute value already by setting it equal to the positive and the negative, and we're trying to find what values x can be. So now if I'm solving, I would add 5 to both sides. 7 and 5 make 12. Divide by 4, and x equals 3. Or, if we're solving this one, I would add 5, and a negative 7 and a positive 5 give me a negative 2. Divide by 4 gives me a negative, oh, sorry about that. They already accounted for the negative right here, so I'll write negative 1 over 2. So let's plot this. A negative 1/2 is here, or x can equal 3, and that's here. So again, these are the two values that make this statement true. So for the your turn, you're going to want to go ahead and do the two steps we talked about. Step 1 is isolate the absolute value. And step 2 is to split where x equals a or x equals negative a. So that argument inside of the absolute value has to equal both the positive and the negative of what's over there after you've isolated the absolute value. Oh, I said it, but I didn't write. There you go. So I'm going to move on to the next page. So I'm now on page 603. I'm going to go through Explain 2. And we're going to solve absolute values with fewer than 2 solutions. So we're still going to do those same steps where we isolate the absolute value expression and then we split it in order to determine what the solutions are. So if it can be solved, you're going to find the solution. If you can't find it, then it's no solution. So let's see what that looks like. So in part A, we subtract 2. And we divide by negative 5. Now when we do that dividing by negative 5, that 10 divided by negative 5 gives me a negative number. Can the absolute value or distance ever equal a negative number? No. Absolute values are never negative. It's no solution. So that's what it means when it says, if so, finish the solution. Well, you can't finish that. Doesn't make sense. Okay, on the other hand, we have part B, which we can add 3 to both sides, and we get 0. When we multiply by that reciprocal, that 5 over 3 to both sides, the 5 and the 5 reduce to 1, the 3 and the 3 reduce, and 0 times anything is 0. So this we can continue, but we wouldn't write 2x minus 4 equals 0 and 2x minus 4 equals negative 0, right? That doesn't make sense. So we only have one equation to solve in this case, which is just 2x minus 4 equals 0. So add 4, and you get 4. Divide by 2, and you get 2. So in this case, we just have the one solution. So we've gone through the case where there's 2 solutions, no solution, and now one solution. Now remember, this is a video, so if you didn't quite catch something, you are more than welcome to go back and rewind and get that help that you need. And pause even if you needed to go finish the your turns that we have discussed or the reflex. Hope this video helped. Thanks.